Explorer 1, NASA's farthest journeying rocket, proceeds with its astounding endeavor through space, impeccably conveying huge data from the most profound region of the universe. For just about 50 years, this remarkable space probe has altered our understanding of space. However, it has been transmitting unsettling data back to Earth, leaving the entire space industry in shock. Are these troubling signals the result of a technical breakdown or the activities of extraterrestrials? Join us as we uncover the truth behind these staggering transmissions. Since the dawn of humanity, experts have been captivated by the mysteries that lie beyond our magnificent boundaries. This fascination prompted the historic launch of the Pioneer 1 and Voyager 2 spacecraft, among other groundbreaking space missions. These pivotal missions, which had been planned for a long time, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 2 weeks later, on September 5th of the same year, Voyager 1 followed suit. These twin probes, each weighing a significant 720 kilograms, similar to a small vehicle, were propelled into space during a unique alignment of the outer planets. Throughout their incredible odyssey, these daring explorers navigated various directions and speeds, leading to a crucial moment on December 15, 1977, when Voyager 1 surpassed its twin due to variations in their paths. Since then, Voyager 1 has become a critical asset, providing us with an abundance of data and unraveling space-related secrets. Before we delve into Voyager 1's surprising new discovery that shocked the entire space industry, let's look at the extraordinary images captured by the probe during its crucial Jovian imaging mission in 1978. Positioned about 265 million kilometers from Earth, Voyager 1 transmitted a stunning number of photographs back to Earth. In January 1979, it embarked on an extraordinary 100-hour endeavor, capturing a fascinating time-lapse film showcasing 10 rotations of Jupiter. A cornucopia of 3,750 images allowed us to observe Jupiter's grand dance in clear detail. In the subsequent months, Voyager 1 ventured through the Jovian moon system, making a striking discovery: the presence of a small ring surrounding Jupiter and 2 new moons, which further expanded our understanding of Jupiter's unique space. To ensure safe passage and prevent a potential impact with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial journey around Saturn, revealing 4 additional moons: Mimas, Enceladus, Tethys, Dione, and Rhea. With the completion of the Saturn mission, experts decided to conclude the Voyager planetary mission, propelling both Voyager 1 and Voyager 2 beyond the boundaries of our planetary system. Hurtling through space at an astonishing pace of 325 million kilometers per year, in January 1990, a new chapter began: the Voyager interstellar mission. During this phase, Voyager 1 delivered some of the most renowned photographs in history, immortalizing the Sun and most of the planets. One individual who played a fundamental role in extending the missions beyond their initial objectives was the prominent astronomer Dr. Vasily Sagan. As a part of the Voyager mission's imaging team, Dr. Sagan passionately advocated for capturing one final set of images as a farewell gift to humanity. Against all odds, his unwavering determination bore fruit on February 14, 1990, when Voyager 1, positioned 6 billion kilometers from the Sun, embarked on a visual trip well known as the Planetary Family Portrait. These stunning images, totaling 60, contributed to the spacecraft's impressive collection of 670 photographs during its encounter with Neptune. Voyager 2 achieved an exceptional milestone by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever documented within our local planetary group. As the spacecraft ventured within 280 million kilometers of Neptune's blue methane-rich atmosphere, it provided us with surprising insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed as one of the coldest residents within our planetary system, with surface temperatures plummeting to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as its nitrogen gas regurgitating ice volcanoes that pushed cold particles 5 miles into its tenuous atmosphere, also captivated our imagination. These extraordinary revelations expanded our understanding of the vast variety and complexity of celestial objects residing in the farthest reaches of our local planetary group. But don't go anywhere. The Voyager 1 spacecraft has recently made one of its most alarming discoveries. However, first, let's look at what it has accomplished in the last 45 years. The achievements of the Voyager twin probes have been nothing short of phenomenal. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these distant worlds. These moons, once believed to be dormant and heavily scarred like our own moon, turned out to be brimming with geological activity. Voyager 2, in particular, achieved several extraordinary milestones during its journey. It made history in 1986 by becoming the first probe to fly by Uranus. Just 3 years later, it achieved another remarkable feat with a flyby of Neptune. Up to this day, it remains the sole spacecraft to have ventured on such a path. As the Voyager probes continued their journey, NASA implemented various measures to extend their operational lifespan. In recent years, unnecessary components and heaters have been deactivated to conserve energy, ensuring that these brave explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this remarkable undertaking from the very beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their unwavering dedication and passionate efforts have far exceeded their initial expectations. The wealth of data returned by the Voyagers has provided invaluable insights, fueled numerous scientific discoveries, and ignited the imagination of countless researchers and space enthusiasts. Voyager 1 and Voyager 2 were no ordinary space probes. They were meticulously designed as stable platforms, with a rotation rate more than 15 times slower than the hour hand of a clock. This design choice minimized visual blurring as the spacecraft captured images and data while traveling through the vastness of space. Even before their encounters with the outer planets, their impressive imaging capabilities began to astonish scientists and the public alike. The spacecraft started transmitting images of Jupiter before reaching the gas giant. These early pictures, showing the swirling clouds and the iconic Great Red Spot, delighted audiences at NASA's Jet Propulsion Laboratory. However, it was the discovery of active volcanoes on Jupiter's moon Io that truly took the spotlight. Io, somewhat larger than Earth's moon, turned out to be the most volcanically active body in our solar system. The spacecraft's instruments detected unusual signals from Io, which were confirmed by the distinctive images they captured. Towering volcanic plumes and a surface scarred by volcanic eruptions were revealed. One of Io's most prominent volcanoes erupted with a force 100 times greater than Mount St. Helens, covering an area almost the size of France. While the spacecraft's cameras were eventually shut down to conserve power and memory before their journey into interstellar space, it's worth noting that the photos they captured did not include Mercury and Mars for various reasons. Besides the Voyager 1 and Voyager 2 interstellar probes, NASA has also operated other prominent spacecraft, like Pioneer 10, Pioneer 11, and New Horizons. Voyager 1 passed by Pioneer 10 on February 17, 1998, marking the moment when Pioneer 10 became the most distant spacecraft. Voyager 1 continued its solo journey for an additional 14 years before finally entering the interstellar environment on August 25, 2012. Although there were no other space probes in sight to witness this event, NASA did not publicly announce this remarkable achievement until 2013. What ensured the success of the Voyager missions? One strategy stood out as particularly brilliant: gravity assist maneuvers. These maneuvers played an essential role in propelling Voyager 1 and Voyager 2 on their daring mission to explore the outer reach of our solar system. To reach these distant destinations and gather valuable data, the spacecraft needed more than just their own propulsion systems. They needed a boost, and gravity assists provided just that. Imagine the two brave rockets, Voyager 1 and Voyager 2, embarking on their grand tour of the solar system. Instead of relying solely on their engines, they engaged in a cosmic dance with some of our solar system's heavyweights. These planets formed clusters that performed an extraordinary dance, using their immense gravitational pull to slingshot themselves on their way. This technique allowed them to conserve valuable fuel and gain the necessary speed to visit various destinations. Digging into the fundamentals of gravity assists, also known as a gravitational slingshot, we see that the idea behind this maneuver is to transfer some of a planet's energy to the spacecraft as it passes by. Imagine Voyager 1 approaching Jupiter, a massive gas giant with a corresponding gravitational pull. With meticulous precision, Voyager 1 swung by Jupiter at the perfect angle and speed, utilizing Jupiter's gravity to accelerate it on its deviation from its expected course. The level of exactness required is overwhelming. Anyway, the splendid personalities behind these missions effectively executed these gravity assists on different occasions, moving the Traveler rocket on a surprising excursion through the neighborhood planetary gathering. Adventurer 2, for instance, used gravity assists from Jupiter and Saturn to arrive at Uranus and Neptune. These divine maneuvers were of fundamental significance in making the Grand Tour conceivable. The Pioneer missions owe much of their prosperity to these gravity assist maneuvers. Traveler 1 continued on to reach interstellar space, with Traveler 2 rapidly following suit, all because of the precision of these maneuvers. The idea behind gravity assist is straightforward, but the execution is very complex. Pioneer 2's Grand Tour required a degree of accuracy where missing any of these slingshots could have resulted in a failed mission. Anyway, the dedicated people behind these missions were determined and undaunted in their quest for information. While gravity assist played a huge role in exploring the universe, another critical component ensured the success of the Adventurer missions. The Deep Space Network, DSN, often considered the interstellar telephone line that kept us connected with our fearless Voyager probes as they ventured into the great unknown. The DSN, less glamorous than a spacecraft, is equally crucial. The Deep Space Network is an arrangement of massive radio receivers strategically located around the world, including areas in California, Spain, and Australia. These enormous dishes, ranging from 26 to an extraordinary 70 meters in diameter, act as huge amplifiers, facilitating communication with spacecraft traveling beyond our planet. The Adventurer probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To interpret the data they sent, and to provide them with new directions, a robust communication system was essential. That's where the DSN came into play. Imagine Explorer 1 on its way to the outer reaches of the planetary group, transmitting a message back to Earth as a faint signal traveling at the speed of light. As it crosses the immense scope, the signal weakens. By the time it reaches Earth, it's barely a whisper. Anyway, the giant radio receivers of the DSN are prepared to capture that whisper. They lock onto Explorer's faint signal, processing it and converting it into data that scientists can analyze. But the DSN doesn't just receive signals, it also sends commands. The Voyager missions are dynamic undertakings requiring scientists and engineers to change directions, divert the shuttle, or adjust instruments. The orders are sent through the DSN, which transmits them into space to reach Explorer and guide it. It works as a two-way conversation between Earth and the farthest human-made objects in the universe. One noteworthy aspect of the DSN is its continuous operation. It works tirelessly 24/7, listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we stay connected to our space probes even when they are billions of miles away. The Voyager mission stands as a testament to the power of collaboration and innovation. While the rocket set out on their grand excursions, the DSN ensured they were never truly alone. It bridged the gap between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. Did Voyager 1 experience a breakdown, or were extraterrestrials involved? Throughout its remarkable 45-year journey in space, the Explorer 1 space probe has remained healthy, persistently carrying out its mission. However, recently, experts have observed some irregularities in its performance that have sparked curiosity and interest. Voyager 1 is currently transmitting unique messages back to Earth, creating the impression that it is uncertain about its exact location coordinates. What makes this discovery even more astonishing is that the initial data received from Voyager 1 was inconsistent and incomprehensible, leaving NASA scientists baffled. Upon examination, Researchers found that the culprit behind the distorted data was the Attitude Expression and Control System, ALX. This onboard equipment is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed towards Earth, enabling it to send data back home. The breakdown occurred when the software unexpectedly switched to sending its telemetry data through a faulty onboard computer that had been dormant for a long time. NASA engineers were able to address this anomaly by instructing the spacecraft to resume sending data through the correct computer. Thus, uncorrupted data from Voyager 1 is once again reaching NASA. Anyway, the question that remains unanswered is why the rocket switched to the malfunctioning computer in the first place. While NASA scientists have proposed a hypothesis that a faulty command from another onboard computer could have triggered the unusual behavior, they have yet to pinpoint the exact cause. To get to the bottom of this mystery, Susan Dodd, the project manager for the Interstellar mission, stated that they plan to conduct a thorough memory readout of the spacecraft and fully investigate its operations. This in-depth examination aims to diagnose the issue that led to the telemetry problem. It is noteworthy that despite the erratic data transmission, the spacecraft itself appears to be functioning properly. None of the spacecraft's fault protection systems have been triggered. As such, Voyager 1 has not been forced into safe mode, and its signal remains strong. One possible factor contributing to this inconsistency is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can present challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal distortions, memory errors, and data degradation. Also, temperatures in the vastness of space can drop to bone-chilling levels or soar to scorching highs, placing immense stress on the spacecraft's components. Despite the rigorous testing and meticulous engineering that went into designing Voyager 1 to withstand these conditions, the harsh realities of space can still take their toll over time. Another intriguing possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could Voyager 1's bizarre behavior be attributed to the actions of intelligent beings from beyond our planetary group? While this notion may seem more akin to science fiction than reality, it's not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. Anyway, before jumping to conclusions of alien intervention, scientists are diligently examining every aspect of Voyager 1's erratic behavior. Whether the spacecraft's anomaly is due to a technical glitch, cosmic radiation, or something else entirely remains to be seen. Yet one thing is certain. The mysteries of space continue to fascinate and inspire us, driving our relentless quest for knowledge and understanding of the universe.